everybody. So we've already had our lesson, our video lesson on Investigation 2, Lesson 4, but this video is a little bonus video because I wanted to go over a couple of more complicated application problems that I did not go over in the original video. So this is just showing you some other ways that we can apply what we've been doing with circumferences and arc lengths and areas. So I'm going to do the two problems on page 82 in your workbook, and you can just follow along in the video. So in this problem at the top of page 82, they give us two concentric circles, two circles that have the same center point P, and one circle is larger than the other. Okay? And they're telling us that in between, the distance between the two circles is some length W. We don't know how much it is. Okay? And they tell us that the circumference of the larger circle, the measure around the outside of the larger circle, is 12 pi more than the circumference around the smaller circle. We have no idea what the radius is for either circle, but all they want us to figure out is what is that difference, what is that distance W that separates the two circles. All right, so this sounds really complicated, but you guys, all we have to work with are the circumferences, okay? So we don't have to figure out areas. This one doesn't even have arc lengths or anything in it. We're just looking at circumferences. So let's think about what we know. We know that the circumference of a circle is 2 times pi times the radius of that circle, okay? So let's think about this. What if we call the radius of the smaller circle, what if we call that radius R for radius? Okay, then the circumference of the smaller circle is going to be 2 times pi times R. And the circumference of the larger circle, so let's think about this. The larger circle, what's the radius of the larger circle? Well, the radius of the larger circle is going to be R plus W, right? To go from the center, not to the inner circle, but all the way to the outer circle, you would go R plus another W. So that circumference is going to be 2 times pi times not R, but R plus W. Okay? And the problem tells us that this circumference is equal to the smaller circumference plus an additional 12 pi. Okay, so let's write an equation. We can take the smaller circumference, 2 pi r, and if we add 12 pi, it's going to be equal to the larger circumference, which is 2 pi times r plus w. At this point, folks, this is just algebra, okay? So the first thing we're going to need to do is distribute here, get rid of the parentheses. So we have 2 pi r plus 12 pi equals 2 pi times r, 2 pi r, plus 2 pi times w. Okay, don't get worried about all these pi's and r's and w's. We just treat them like any other term in an equation. So we have a 2 pi r on both sides. Well, first thing I'm going to do is clean this up by subtracting those so they both become zeros and cancel out. Now I'm left with 12 pi equals 2 pi times w. All right, what do you think we can do next? Well, both sides have a pi, so I can divide pi out. And now I have 12 equals 2w. So what must w be? 2 times w is 12, so divide by 2, and w is 6. All right, so the only hard part was recognizing right away that all we needed to work with were the circumferences of those two circles. And the answer would be B. The W was 6. Okay, let's look at the second problem, number 8, on the bottom of page 82. This one is a little more fancy, a little more complicated, because we're cutting a wedge out of that circle, okay? So this is a situation where we do have a major arc that goes around more than half of the circle, and what they want us to figure out is eventually we need to figure out the perimeter of the whole unbroken circle. So perimeter is the distance around the outside of the figure. So that would be going all the way around this major arc and then going along these two sides of this square. Okay, so here's what they're telling us. They're saying this is the center of the circle, and they're saying that these are radii, a radius and a radius. The plural is radii. Okay. And this is a square, so that means all of these sides are the same length. So all the sides of the square are the same measure as a radius. Okay, and we don't know what the radius is, but look what they tell us. The square has an area of 4x squared. Okay, and you know the area of a square is the side times the side, right? The side squared. So we need something that squared gives us 4x squared, and that's going to be 2x times 2x gives us 4x squared. All right, so we know each side has a length of 2x, and the radius has a length of 2x. Okay, now we're just doing our usual circle stuff, you guys. So what are we interested in? Do we need the area? No. All we need is the perimeter. So all we need is that arc length. And if you remember, how do we do the arc lengths? We do the degrees divided by 360 times the circumference. Well, the degrees, this is 3/4 of the way around, right? Because they're cutting out 1/4 of the circle, because this is a right angle. So if this is 90 degrees in the square that's cut out, then that means this central angle is 270 degrees. It's 360 minus 90, okay? So we're just going to do 270 divided by 360 times. Now the only other thing we need to know what the circumference is. Okay, so if you remember, circumference is 2 pi radius. And what did we say our radius was? 2x. So our circumference is 2 pi times 2x, which is 4 pi x. And we just leave it like that, okay? So we know that we have to take our central angle divided by 360, that's the part of the circle that we want, times the circumference, which is 4 pi x. And we're just going to multiply that out, okay? And that turns out, if you do 270 divided by 360 times 4, that's 3 pi x, okay? So 3 pi x is the distance around the curved part, okay? So this piece here that goes all the way around like this, that piece is 3 pi x. Okay. So we've already got this part of the perimeter figured out. Okay, that's 3 pi x. Now, if we want to go all the way around the figure, what do we still need to add to it? We still need to add, at this point, we have to come down here, and then we have to go across here, and then we've outlined the whole figure. Well, we know how long this side is, it's 2x, and we know how long this side is, it's 2x. So the whole perimeter is 3 pi x. That's the curved part. That's the arc length. Plus 2x plus 2x, which are the sides of the square. Okay. Now they give us 4 options here, and you'll notice that they're factored. So all we have to do is factor this together. So it's 3 pi x plus, we can combine like terms, 4x, and we can factor out an x. Okay, so let's factor out the x times 3 pi plus 4. So does that match any of our answers? So we need an x times, so it's not going to be that one. So these say x times something. We need a 3 pi and a 4. And it's going to be this first one. They just reversed those two numbers. Okay? So 3 pi gets you around the curve. And then the 2x and the 2x get you around the square. And that's it. Okay? So I just wanted to share those two problems with you. Bye, guys.